Hello ladies and gentlemen, we are going to be talking about chemical composition and reactions, which is chapter 8 in your book. We are going to review the section on oxidation numbers because I'm assuming you have forgotten all of what we have talked about a few weeks ago. Okay, first off, what is an oxidation number? If you look right up here in the top right, it says oxidation state, which is the same thing as oxidation number, is the number of electrons that a particular atom can lose, gain, or share with another atom. Now, this is not the same thing as talking about a charge. It is, however, related to it. When you're talking about losing or gaining electrons, that's charge. However, when you talk about sharing electrons, that is only related to oxidation numbers, not charge, because when you share, it's covalent and there is no charge. Okay, the rules for figuring out what those oxidation numbers are. Number 1, the free element rule. All elements in what's called their free state, in other words, when they are not combined with something else, have an oxidation number of 0. So if you look at the examples, you have sodium, copper, magnesium, all of which are individual atoms. They are not bonded to anything, so their oxidation number is 0. However, you have hydrogen, oxygen, and nitrogen, which naturally form a diatomic atom. In other words, two atoms of the same kind together. They still will appear as having an oxidation number of 0 because they're not combined with other elements. Okay, a nice simple rule is the ion rule. The oxidation number of an ion is the same as its charge. Okay, that does not mean that its oxidation number is its charge, however, it has the same value. So if its charge is a -1, its oxidation number is a -1. And remember, an ion is just an atom or a couple of atoms that have a charge. So that's nice and simple. Okay, the zero-sum rule. Sum, remember, is adding. So when you have the sum of all of the oxidation numbers in a compound, the overall sum of those oxidation numbers has to be 0. So if you're talking about sodium over here, and chlorine, which combine together to make table salt, sodium chloride, you have to have the overall oxidation number, once they're combined, be a 0. Okay? We know from other rules that you're about to learn about that sodium has a +1, chlorine has a -1, and hopefully your math will add those together and get you a 0. If they do not have the same oxidation, they still need to total a 0. Magnesium has an oxidation of a +2. Chlorine only has a -1. So that means that you have to have 2 of them to get a total of a -2, so that you have +2 and -2 to get you to that 0 for the whole compound. And that's why it's MgCl2, is you have to have 2 of those chlorines together. Okay, now there are actually a number of specific oxidation number rules, which basically means that those elements will have the same oxidation number over and over again, no matter what, with few exceptions, if they are in compounds. Okay, first off, group 1, the alkali metals. The group all the way to the left on the periodic chart, group 1A. They will always have a +1 oxidation number when they're bonded to other things. Okay, group 2, alkaline earth metals right next to group 1 on the left side. In the same way, they're going to have a +2 oxidation number when they're in compounds. So their group number automatically tells you what their oxidation number is. You just need to remember that they are positive on the left side. Okay, hydrogen, remember, acts like an alkali metal over on the left and acts like a halogen over on the right in group 7A. Hydrogen acts like both of those. So when hydrogen is bonded to another nonmetal and it's acting like a halogen, or like an alkali metal, it will have a +1 oxidation number. When it's acting like a halogen over on the right side and it's bonding to a metal, it will have a -1 oxidation number. Okay, so hydrogen and a nonmetal +1 oxidation because it's acting like an alkali metal. Hydrogen and a metal bonded together. Remember, that's everything to the left of that zigzag on the periodic chart. Will have a -1 oxidation number because it's acting like a halogen. Okay, oxygen will have a -2 oxidation number, except for a couple exceptions, primarily when it's bonded to fluorine, because fluorine has a lower electronegativity. Just realize it bonds more easily. So oxygen, just assume, unless it has to be different, that oxygen has a -2 oxidation number. Okay, the halogens, mentioned those with hydrogen, group 17 or 7A, depending on how you look at it, all the way to the right except for the noble gases, will always have a -1 oxidation number. Okay, so that's like the hydrogen. When it's bonded to a metal, it's acting like a halogen. It will have that -1 oxidation number. Okay, these are some examples of polyatomic ions. These overall are going to have charges with them. These are ions in themselves. So when you look at ammonium, NH4+, which by the way is the only positive polyatomic ion, the whole thing has a +1 oxidation number. Acetate, C2H3O2, has a -1 oxidation number. Okay, and you can see, because they are ions, they have the same oxidation number as they have the charge. Okay, so whether you're talking about an individual element that has a charge, a single ion, monatomic, one atom, or whether you're talking polyatomic, it is going to have the same oxidation number as its charge. Regarding that worksheet that you did before the break, just forget about it. I never should have given to you. It was confusing, and I'm going to be giving you my own instead of trying to giving you someone else's, which was confusing. So I apologize for that, and you will see your own soon. Okay, you need to review these rules. It is to your benefit to memorize them, because